And now we have entered to our second demonstration, which is to analyze memory leak with .NET counters and .NET-dump. So this have two parts. So let's continue with the part one. So before we go there, we'll have a look at in our code again. For some memory leak issue, I have created these two methods over here. So what this method does is this will get a slab from our collection over here, and it will convert into a byte array object. This byte array object will be adding to the list that we have created over here. So since this is in a while loop, this same object will be keep adding to the list. And the second method is to convert our object into a byte array. Since these objects are written by our program, this will cause a memory leak issue. So we'll see how we are going to find that one using the .NET-dump analysis. Let's go back to the slide and we'll I'm going to skip this part because we already know that one. Okay, I'm going to monitor this one, and I'm getting ready to create the dump file for our application. Okay, once we uh, execute the method, see what happens to the GC heap size. Okay, you'll see our GC heap size is getting bigger and bigger. So since this is memory, we know exactly that's our application. It suffers from a memory leak issue. So we are going to create a dump file for further analysis. Just like we did before, I'm going to drag and drop this to Visual Studio. So our aim is to find the object type that causes this trouble. So that clue will be helpful to identify the method that has the error code snippet. Okay. So I'll be doing the analysis on our app's memory usage. On the analyze result, I'm going to skip this one since it takes a few minutes, few time. Okay. On the result set, I'm going to click large object heap. So this will show the objects that are sizes bigger than 85 kilobytes. So we can see our byte array is taking up to 256 megabytes, which is quite large. So this happens because our objects is not released properly in our application. So this causes a memory leak issue. So these findings will help us to pinpoint the exact operation, and then we can apply the fix for it. So we can have the same finding using the PowerShell tool. We'll go and have a look at. Go and have a look how we are going to do this. Okay, the part two. In here, now we are going to use the analyze command. Taking our So we have to define our dump file name over here. Okay, now it's ready to process the analysis. So since we are interested in memory, I'm going to start with the dump heap command. So dump heap will get addresses of all the instances. Okay, what we got here is the method table. So method table will helps to identify the type. We have the memory addresses and number of occurrences on the second column, total size, and the class name. So as we go down, we will be finding the biggest memory address, which is system.byte. We found the same one using Visual Studio in previous slide. So what we are going to do is we are going to further analyze this memory address. So we'll start with the dump heap again, dash empty, since we are addressing since we are looking for a memory address. And so this will list down all the single instances of our byte array. So I'm going to select a random memory address from here and continue the gc root. Continue with the gc root command. So gc root will traces all the references, keeping our object alive. Okay, these are garbage collected targeted objects. So it is waiting them to release so the garbage collector can pick it up. There are 107 unique routes, means there are 107 separate object references keeping our object alive. So this also includes the stack tracers. So means how the object is allocated. So since we don't need that, we only need the direct GC routes. So I'm going to start with the same command with no stack attribute. Okay, we have found only two unique routes for our object. Strong, strong handle means this object won't be garbage collected. So in here, in this reference chain, so there's an instance of our electricity service class, and also that holds a reference to a list which contains array of array, and finally we have the array object that remains in the memory. So this tells our service classes indirectly held our byte arrays. So we can go to our code, find the method that matches to the exact description, and apply the fix our application desperately needs. So we have so what we have found here is there is a method in our service class that generates system.byte arrays and also kept them in a list. So we can locate that exact method and apply the fix for it. So this is how we trace a memory leak by identifying the root references using dotnet-dump and with the help of dotnet-counters. Okay, now the second demonstration is over.